I welcome you all to this lecture 4 of this course, Construction Methods and Equipment Management. So, in this lecture we are going to estimate how to estimate the operating cost associated with the equipment. So, let us have a recap of what we learnt in the previous lecture. So, in the previous lecture we have seen how to estimate the ownership cost using the time value method. So, this is the outline of today's presentation. I will just introduce to you what are all the components of the operating cost of the equipment. So, we will work out some illustrations on the estimation of the various components of the operating cost. Then we will also discuss how to estimate the total equipment cost using two different methods. One is Caterpillar method, other one is the Purify method, which are the commonly adopted methods for equipment cost estimation. So, what are these operating costs? So, basically these operating cost occurs only when the equipment is used. So, unlike your ownership cost, when we discussed about the ownership cost, I told you that the ownership cost is incurred irrespective of whether the equipment is operated or not. Even if your equipment is idle, we are going to bear the ownership cost. Okay? But in the case of operating cost, the operating cost occurs only when the equipment is used. Okay? This will be highly variable cost. Okay? It depends upon the usage of the equipment. But your ownership cost or generally relatively fixed cost, fixed annual cost, okay, every year. But this cost is highly variable, it depends upon the usage of your machine. First, let us see what are all the components of the ownership cost. So, basically you have these consumables, okay, they come under the operating cost. Your fuel, lubricating oil, filter, grease and all the other small components which are getting consumed during the equipment operation. Okay, all these are called as consumables. So, this forms a part of the operating cost. Then the wages what you pay for the operator, that is a part of operating cost. Then your maintenance and repair cost. So, this maintenance and repair cost can be either major or minor. Okay, say the major maintenance and repair cost means involves huge replacement of a particular part of the machine. It involves huge investment. So, those things, the major repair will be major repair or usually considered or accounted under the ownership cost. So, only the minor repair cost is considered under the operating cost. Say for example, you have an excavator, okay, so you are going to change the complete boom of the excavator, okay, so that will be a major investment, okay, so that will come under ownership cost. Say you are going to just replace some small parts of the machine, say you are going to change the wiring or you are going to change some small parts like the headlight, okay. So, in that case it will be a minor repair and it will be considered under the operating cost. Okay. So, we will be discussing all these components in depth in the upcoming slides. Okay. So, one thing what you need to know is your operating cost will vary with the usage of the machine. Okay. It varies with the number of operating hours of the machine. The more you use the machine, the more will be the fuel consumption, more will be the repair cost. Okay. So, the operating cost will also be more. It depends upon the usage. Similarly, it also depends upon the job operating condition. A same equipment, if it is put under two different types of operating condition, one is put in a very severe or tough operating condition, one is put in an average operating condition. In both the cases, you can see a significant difference in the operating cost. Okay. Say for example, an excavator. Okay. So, one is working in a quarry. Okay, one is operating in the quarry. Okay, so it is used to excavate the short rock pieces. So, the other excavator, it is used in the common the construction site where it is handling the ordinary earth. So, when you compare the difference between these two excavators, you can see the one which is working in quarry is in a severe condition or tough operating condition. Okay, we can also call it as unfavorable working condition. Okay, so in that condition, the operating cost will be more, the fuel consumption will be more, power consumption will be more. Okay. So, its repair cost, wear and tear will be more. So, the same machine when put under different operating conditions, okay, you can see the difference in the operating cost. So, we can give n number of examples in this perspective. Say for example, a pile driving equipment. Okay, we are going to discuss all these machines in detail in the upcoming lectures. Okay. The pile driving equipment I am using for two different sites. In one particular site, you have a very cohesive clay. In another particular site, I have the ordinary earth. Obviously, the one which is working in the cohesive clay will incur more operating cost. Its wear and tear will be more, power consumption will be more, fuel consumption will be more and the repair cost will be more. So like this we can give a number of examples. So it basically, the operating cost depends upon the nature of job also. It depends upon for what job you are using the particular equipment. Say for example, an excavator, the same example, I am using it for excavating the earth. I told you earlier also in the previous lecture that the excavator is commonly used for trenching and pipe laying, okay, because the same equipment can do the complete entire process. Okay. So when I use the excavator for trenching, when it is excavating, its power consumption will be more. Then later when I use it for only for pipe laying, I will just change the attachment, I change the rigging device and I handle the pipe with the help of excavator. That time you can see that the power consumption, the fuel consumption will be less. Okay. So the operating cost will vary depending upon the nature of the job. Similarly, you can compare different examples. Say for example, you can consider an aggregate crusher. Okay. It is subjected to a very severe operating condition, you can say. Okay. It is subjected to more amount of wear and tear. So its nature of job is very tough. So the amount of operating cost invested in this machine will be more when compared to other sophisticated machine like a electric motor. You compare an aggregate crusher with an electric motor. Okay, this is more sophisticated machine. So the operating cost involved in this machine will be less. So it depends upon the nature of the job. So generally the equipments which are more subjected to more mobility, okay, they are more subjected to wear and tear, their operating cost is more. The equipments which are more stationary, okay, which are subjected to less amount of mobility, okay, and which are not used continuously, okay, in those cases you can see that the operating cost will be less. So it is highly variable, your operating cost is highly variable. Okay. Now, so how to estimate these operating costs, how to get information on all these operating costs, that is very important, because basically you can get this information from your past experience records. If you have accounted all the information, consolidated and you are accounting the information properly, from your past experience records you can get the information. If you have worked with a similar equipment in similar site condition or operating condition, so those fuel cost or the lubricating oil cost or the repair cost you can make use of for the equipment cost estimation. Otherwise you have to go for the manufacturer recommendation. Okay. So most of the equipment manufacturers, okay, they supply equipment handbook. Okay. So in that particular handbook, for every model they have manufactured, they give the information on the fuel cost estimation, lubricating oil estimation for different operating conditions. Okay. Similarly, what will be the repair cost, what will be the tire life. Okay. So all this information I can get it from the manufacturer guidelines also. So there are different handbooks available. Okay, we can get this information from the appropriate handbooks. So now let us discuss about the operating cost one by one in detail. The first one which we are going to discuss is about the maintenance and the repair cost. So this contributes to significant proportion of the operating cost of the machine. So basically as your machine age increases, okay, as your machine ages, obviously your repair cost will increase, your repair and the maintenance cost is going to increase because your machine has been subjected to more amount of wear and tear. So it is almost worn out, you have to replace some components, okay. So cost of those replacement parts, okay, so you have to replace some components, right, the cost of the replacement parts. So for repair work you engage some labor, okay, so the labor involved for the repair work. So all these will come under the maintenance and repair cost. Generally for a contractor who has a good equipment fleet, so what he does is he will have a maintenance facility, okay, in his site. He has a maintenance facility on his own, okay. In this maintenance facility he will periodically maintain his equipments. He will do periodical checkup of the machine, timely service, okay. He will do cleaning of the machine, okay. So he will engage some labor there, okay, to do the maintenance operation. So to set up this facility also some cost is involved. So all these things makes up the maintenance and the repair cost. So as we discussed just now, we can see that the maintenance and repair will considerably vary with the type of the equipment and the nature of the job. The one which is subjected to severe working condition or tough working condition or unfavorable working condition, so that will be incurring more amount of repair cost. Okay, it will be more worn out than the sophisticated machines which are subjected to average working conditions. So it will depend upon the type of equipment and the nature of the job. and your cost, maintenance and repair cost, will depend upon the care it receives. Okay. So, the preventive maintenance is very important. Preventive maintenance, it is very important for any job. Okay. So, basically if you have your own maintenance facility and if you periodically maintain your equipment, periodically do the checkup, okay, and do the timely service for the machines, do daily cleaning of the machines. If you take care of your machine very well in this way, you can extend the life of the machine. Okay. Your machine life will get extended and your operating cost will get reduced. How the operating cost gets reduced? Because you can reduce a major breakdown of the machine. So, the major repair will get reduced. Okay, that will significantly save your total cost. So, that is why it is always preferable to go for the preventive maintenance. We have to take care of the machines properly. So, this we have discussed just now. Maintenance and repair tends to increase with the age of the equipment. We know the reason already. So, generally the maintenance and the repair cost, if you look into the literature, there are different ways by which it is estimated. Okay. In some literature, they express it as a percentage of the annual cost of the depreciation of the machine. So, percentage of the annual cost of the depreciation of the machine. In some cases, you can see that the lifetime repair cost is estimated as a percentage of equipment's initial cost. So, there are different ways by which you can estimate it. Okay. But when you estimate it as a percentage of equipment's initial cost, you are supposed to deduct the tire cost. That is very important, because the life of the tire is different from the life of the remaining part of the equipment. So, its depreciating rate is also very much different when compared to the remaining part of the machine. So, the repair cost of the tires will be considered separately. So, we won't consider it along with the remaining part of the equipment. So, that is why you take the lifetime repair cost of the machine excluding the tire. It is estimated as a percentage of the equipment's initial cost minus the tire cost. So, you can see the values are available related to the lifetime repair cost. You can get the lifetime the repair factor as a percentage of the initial cost of the machine without tires for different types of equipment for different operating conditions. Okay, like favorable, average, unfavorable. Okay. So, for different operating conditions and for different equipment type, you can get these values from literature. So, these values are taken from Gransberg. You can find this similar kind of information from different literature also. So, you can make use of this information to estimate your repair cost. So, one thing I wanted to tell you here is your lifetime repair factor, that is, the repair factor depends upon the type of the equipment. Okay. There are different types of equipment. Just to show some sample values, I have just represented only crane and the truck. It is called as off-highway the truck. Okay. These trucks are not permitted on the public highways. That is why it is called as off-highway truck. It is used in the site, construction project site or quarries, okay, wherever. So, this you can see based upon your operating condition as well as based upon the equipment type, your repair factor is varying a lot. So, basically when you compare crane and the truck, you can see the repair factor is more for the truck when compared to crane. Obviously, we know the reason, because the truck, it is a highly mobile machine. We use it continuously and its mobility is also very high. It is subjected to high mobility. Okay. So, that is why its repair cost will be more when compared to crane, which is not highly mobile. Okay. So, we do not use its mobility to a greater extent, and also the crane usage won't be continuous like truck. It will be used in an intermittent way. The crane is used intermittently when compared to truck. That is why you can see the repair factor is less, but in the truck the repair factor is high. Similarly, when you compare the unfavorable condition with favorable condition, you can see that in unfavorable condition the repair amount is very high. Say a truck is operated in a rocky terrain, so on a steep terrain, poorly maintained haul roads. In that case, obviously that is unfavorable condition. So, you can see that obviously your repair factor will be more. Same truck when it is operated on a properly maintained haul road on a gradient which is not very steep, in that case that is called as favorable condition. You can see that the repair factor is less, okay, 70 to 75%. So, you can see in the literature even the definition of the operating conditions will be given for different types of equipment. You can find those information in the equipment handbooks. Now, let us see how to estimate the hourly repair cost for a particular year. Say this formula, if you remember, This is somewhat similar to what we used for estimation of depreciation using sum of the years digit method, something similar to that. So, the hourly repair cost for a particular year, how to calculate. So, say for example, you are going to estimate it for the second year of the equipment operation. So, then you have to put the year digit as 2 and the sum of the years you have to take what is the total n. Say the useful life of the machine is say 5. Then the sum of the years digit will be 1 plus 2 plus 3 plus 4 plus 5. So, multiplied by the lifetime repair cost. So, lifetime repair cost, you know it, depending upon the type of the equipment, depending upon the operating condition, it is expressed as a percentage. Say for example, if it is 90% of initial cost minus tire cost, okay, initial cost minus your tire cost, okay. So, divided by the total operating hours of the machine in a year. So, operating hours of the machine in a year. So, this will give you me hourly repair cost for a particular year. Now, let us work out an example on how to estimate the repair cost. Okay. Estimate the hourly repair cost of a scraper for the second year of the operation. So, the initial cost of the scraper is 82 lakhs. I have retained the same input data from the beginning. Okay, you can see the tire cost is 6 lakh and the useful life of the machine is 9 years. And assume the average operating condition. So, operating condition is given to you. The scraper is working in an average operating condition and the annual usage of the machine in hours is operating hours of the machine in a year is 2400. Expected life of the tire for average working condition is 3000 hours. So, this information also you can get it from the handbook. The manufacturer can provide you the data. So, what will be the expected tire life for this working condition? You can get it from the manufacturer guideline or you can go with your past experience data. So, in this problem it is given to you directly. Then the lifetime repair cost for this scraper machine is 90 to 95% of the initial cost of the machine without the tires for average working condition. Okay. So, the factor is also given to you directly in this problem. So, you need not search for this factor in any equipment handbook. So, the values are directly given in this problem. If it is not given, you have to look into the handbooks, equipment handbooks or the manufacturer guidelines. Now, let us estimate the lifetime repair cost. Okay. It is nothing but it is given as 90 to 95% of the initial cost. So, this value I am just taking it as 90%. Okay, 0.9 into initial cost minus tire cost. 0.9 into 82 lakh minus 6 lakh. It is comes around 68 lakh 40,000. That is your lifetime repair cost. Now, I can calculate the hourly repair cost for the. They have asked you to find it for the second year of the equipment operation. So, the year digit, the numerator you have to put as 2, then in the denominator sum of the years digit. So, what is the total life of the machine? N equal to 9. So, how did you get this 45? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. So, sum of the digits in the life of the machine, that will give you 45. Now, what is the lifetime repair cost? So, you have estimated it already. Okay. You can put the lifetime repair cost as 68 lakh 40,000 divided by the hours operated in a year, that is nothing but 2400. Okay. If you multiply, you can get the value as 126.67 okay, per hour. Okay. This is your hourly repair cost for the second year of operation of this particular machine. So, this is how we estimate. So, now let us see how to estimate the tire cost. Okay. So, this tire cost is really a little bit uncertain and more difficult to estimate because there are so many factors affecting the tire cost and the tire repair. So, it depends upon the life of your tire. The life of the tire is highly variable. It depends upon your project condition. It is highly variable. It also depends upon your operator skill. Okay. So, with a very good operator, the tire may last for a longer time. With a very poor operator, the tire may last for a lesser life, maybe lesser. Okay. So, it is really a little bit difficult to estimate, but anyway you can get this data from the past your experience record with a similar equipment and similar operating condition, or you can go for the information in the equipment handbook, okay, as given by the manufacturer. Basically, tire cost represents the cost of the tire repair and the tire replacement. Okay, the life of the tire is very much different. It is lesser when compared to the life of the remaining part of the machine, and the depreciation rate of the tires will be quite different from the rest of the vehicle. Obviously, your tire will depreciate at a faster rate when compared to the other part of the equipment. That is why we are calculating the tire cost separately. See, if you do not have much information on the tire repair cost, you can just add 15% to the tire replacement cost to determine the tire repair cost. Okay, just add 15% to the tire replacement cost to find the tire repair cost. Okay, as I told you, you can get this information about the tire life, tire cost and the tire repair. All this information you can get it from your own past data, okay, or from the manufacturer guidelines. Okay. Now, let us see how to estimate the tire repair and replacement cost for the previous problem. So, I am just assuming that repair cost will add to 15% to the tire replacement cost. So, I multiply 1.15 with the tire cost. So, the cost of set of tires is known to you, it is 6 lakh divided by the life of the tire, 3000 hours. Okay. So, it will depend upon the operating condition. Okay. So, it depends upon the so many factors, as I told you, even depends upon the operator. So, you can get this information from the equipment handbook or from a past experience. So, for this problem, the 3000 hours is directly given in the problem. So, we can estimate it and we can find the value as rupees 230 per hour. It is your tire repair and replacement cost. So, now let us see how to estimate the consumable cost. So, consumables also forms a part of the operating cost, as we know. Your fuel, the lubricating oil, grease, filter, all the other small parts, whatever small components what we use which are consumed during the operation of the machine, they are called as consumables. So, under that first we are going to discuss about the fuel cost. So, the amount of the fuel consumption, it depends upon the engine type. So, all the construction equipments are basically IC engines, okay, internal combustion based engines, which may be either diesel operated or gasoline operated. So, your fuel consumption, it is going to depend upon the horsepower of the machine, that is very important. Okay, it depends upon the type of your engine, okay, and the horsepower of your machine. So, the amount of fuel required to power a piece of the equipment for a specific task depends upon the horsepower of the machine. So, greater the horsepower of the machine, your fuel consumption will be more. So, this is one important thing we have to note it. So, depending upon the horsepower of the particular engine or the particular machine, your fuel consumption will be varying. And another important thing is your time factor or the working efficiency, that is also going to affect your fuel consumption. So, basically you know that in 1 hour, so the entire 60 minutes the machine is not going to work. On an average, maybe the machine will be working from either for 45 minutes or 30 minutes. So, depending upon the job productivity needed at your project site. So, your machine won't work for the entire 1 hour. So, that is what is called as a working efficiency. So, how do you find the working efficiency? Say for example, if a machine is working for 45 minutes in an hour, your working efficiency is 45 by 60. So, that gives you the time factor. The actual time the unit will operate in an hour or a day, that is called as a time factor. The next important factor which we are going to consider is a load factor. So, one thing we have to know that your machine may not be working at full power always. So, whenever it is working in a very tough condition or whenever it is doing a very tough nature of job, that time only the power consumption will be maximum. So, remaining part of the production cycle, you can see that the power consumption may be average or it may be more than the average, but it may not be the maximum. So, that thing we have to note it. Say for example, a scraper. Okay. So, scraper is an earth moving machine. Okay. So, we will be discussing about scrapers in the upcoming lectures. So, this scraper is used for the earth moving operation. Okay. So, basically it can cut the earth, okay, excavate the earth and then load it into the bowl. During the cutting operation, the power consumption will be maximum. Okay. It will be working at full power. But when the bowl is full, when it is just carrying the bowl or hauling the material, it will be working at the average power only. So, for how much part of the production cycle of how much time, so it is operating at full power and how much time it is operating at average power, that we need to know, because accordingly your fuel consumption will vary. Similarly, for different types of machine we can consider. that is the importance of load factor, because that is going to influence your fuel consumption. So based upon this time factor and load factor, you can calculate your operating factor. So your operating factor is nothing but your time factor multiplied by your load factor. Now regarding the fuel consumption, okay, as I told you, you can get the information about the fuel consumption for a particular machine, particular type of equipment under a particular operating condition. Okay, so you can classify the operating condition accordingly. So in different literature you can see different types of classification. So just now we saw in the textbook by the Gransberg et al., it was classified as unfavorable operating condition, average operating condition and favorable operating condition. So you can classify this way. Some other different equipment handbooks, if you go through, the definition of the operating conditions, the terminology may be different. Say for example, if you refer the Caterpillar handbook, which is published by the Caterpillar Equipment Manufacturing Company. Okay, it's a very popular company. Okay, so they have published a Caterpillar handbook. So the link of that handbook is also given in the references. You can download the handbook and you can go through what are all the different factors and how they estimate the cost. Okay, it will be very useful to you. So basically, you can see that the Caterpillar handbook, they have classified different load conditions. So load conditions, they have classified it into high load condition, medium load conditions and low load conditions. You can see that, say for example, take an example of excavator. Okay, in the Caterpillar handbook, you can see that for every model they have manufactured. So for every model of machine they have manufactured, for that particular model, you can see the fuel consumption estimation for different load conditions. Okay, if you look into the excavator, a particular model number, you can see for high load conditions, what is the fuel consumption. You can get the value directly, there are tables. And for medium load condition, what is the fuel consumption value, you can get it directly. Similarly for the low load condition, and the definition of these load conditions are also given accordingly. Say high load condition means your excavator is working in a rocky terrain, so it's a tough condition. Also the expected job productivity is 90 to 95% schedule. So they are going as per the expected the productivity schedule of 90 to 95%. So that means the usage of machine is for a more amount of time. Similarly low condition means your excavator is working in a sandy terrain, so which is not very tough, okay, for the excavator. And similarly the job productivity, you can see it is less than 50% of the expected schedule. It is less than 50% of expected schedule. That means the machine is not working for a longer duration. So this they call it as low condition. So the definition of the conditions also define, and for different operating conditions for a different model, what is the fuel consumption value, directly you can take it from the tables. So like this, different equipment manufacturers have published their own handbooks, and in that handbooks you can directly get the fuel consumption value for that particular equipment model. Okay, so then when operating under standard conditions, okay, so these are the theoretical values which we have determined from the literature. So the literature also gives you some standard values. So when a machine is operating under the standard conditions, a gasoline based engine will consume 0.06 gallons of gasoline per flywheel horsepower hour. In SI units, if you see, it is 0.23 liters per flywheel horsepower hour. So if the machine is going to be diesel based engine, it will consume 0.04 gallons per flywheel horsepower hour, or in SI units, it is 0.15 liters per flywheel horsepower hour. So this is the consumption rate, fuel consumption rate given for two different types of engines. One is gasoline engine, other one is diesel engine. So this has been worked out for standard conditions. You can get it from the literature. So standard conditions means your machine is working at maximum output. So this value, whatever, if you are going to use this fuel consumption value for your project condition, you have to adjust this value according to your project condition. You have to adjust this value according to your project condition. Say for example, based upon your time factor, how much time your machine is going to work. Based upon your load factor, for how much part of the cycle it is working at full power. So based upon that, you have to adjust these factors according to your project conditions. Okay, that is what you are going to see. So you can make use of these fuel consumption factors from the literature. but you have to see your project conditions and accordingly adjust and use it. So these are typical values of average fuel consumption factors which are taken from the textbook by Gransburg et al. Okay, it is given in the reference. So he has given this fuel consumption factors for different types of equipments for different working condition, favorable, average, unfavorable conditions. I am just showing you only some sample values. So one thing you can see that the fuel consumption varies depending upon the type of equipment. For a truck and a loader, if you compare, the fuel consumption is relatively more for the loader. You can see that the track mounted loader, okay, it consumes more amount of fuel when compared to the highway trucks. So it depends upon the nature of job it is doing, okay. So it's doing a little bit tougher job, so its fuel consumption will be more. Similarly, unfavorable conditions, you can see the fuel consumption is very high when compared to the favorable conditions. So depending upon that, the fuel consumption is going to vary. As I told you already, truck, you can see that if you work it out on a very poorly maintained haul roads, the fuel consumption is going to be high. Similarly, if you work on a properly maintained haul road, its fuel consumption is going to be less. So the definition of the project conditions also given in the literature accordingly. Next, let us discuss about how to estimate the hourly cost of fuel. Obviously, to estimate the hourly cost of fuel, you need to know what is the fuel consumption. What is the hourly fuel consumption you need to know. What is the hourly fuel consumption multiplied by the unit cost of fuel. If you know these two things, you can estimate. Obviously, the hourly fuel consumption is going to depend upon the type of the equipment and it depends upon your project operating conditions. And the cost of the fuel will vary from place to place. It depends upon what is the cost of the fuel in that local place. So this is going to influence your the fuel cost estimation. So how to find the fuel consumed per hour? You can get the fuel consumption factor from any literature, from the equipment handbook or from any other source of reliable literature. You can take the fuel consumption factor corresponding to the particular type of equipment and project working conditions. Okay. Then you have to adjust the fuel consumption factor according to your operating factor. So operating factor is nothing but your time factor multiplied by load factor. Okay. So according to your project condition, you adjust it, and according to the horsepower of your machine. Greater the horsepower, obviously your fuel consumption will be more. So this is how we have to adjust the available fuel consumption factors which are available theoretically or from the handbooks according to your actual project conditions. Now let us work out an example on how to estimate the fuel cost of the machine. So calculate the average hourly fuel consumption and the hourly fuel cost for a twin engine scraper machine. It has a diesel engine rated at 450 horsepower and the fuel cost in that place is given as rupees 60 per litre, and the fuel consumption for the twin engine scraper operating at average condition is 0.125 litres per horsepower per hour. Okay, the fuel consumption factor is given for this particular machine for the average working condition. So you can directly use it because it is given in the question, otherwise you have to look for the equipment handbook. Then during the cycle of 24 seconds of its production cycle, you can see that engine may be operated at full power while filling the bowl in the tough ground. So it is filling the bowl, the scraper is filling the bowl, cutting the earth and filling the bowl. So for that it needs 6 seconds time. So only during that 6 seconds time it is working at full power. So the remaining 24 minus 6 seconds, okay, remaining 24 minus 6 seconds, during the balance of the cycle, the engine will use no more than 50% of the rated power. So it is working at average power in the remaining part of the production cycle, and its working efficiency is 45 minutes per hour. So your time factor is also given here. So with this input data, now we are going to see how to estimate the fuel cost of the machine. So the horsepower of the machine is given, the rated horsepower 450, engine factor is given. So as I told you, while filling the bowl, it is consuming full power. So it is taking 6 seconds out of the total production cycle time of 24 seconds to fill the bowl. Okay, during this cycle, it is using full power. Okay, 0.25 into 1. Okay, so during the rest of the cycle, that is 18 by 24 seconds, it is using average power, that is into 0.5. So that will give you 0.375. Now you find the total cycle. Okay. So while filling the bowl, it is 0.25. During the rest of the cycle, just for hauling the material, it is using 0.375. So the total cycle amounts to 0.625. Now the time factor, it is working for 45 minutes in 1 hour. So its working efficiency is 0.75. Now the operating factor is nothing but your time factor multiplied by load factor. So this is your the load factor. Okay, so this is your load factor 0.625. Okay, this is your time factor 0.75. If you multiply, you will get the operating factor as 0.47. Assume average fuel consumption factor. So it is given in the question, the fuel consumption factor for this particular type of machine for average working condition, it is given as 0.25 liters per horsepower per hour. Now let us find what is the fuel consumed per hour. So the operating factor multiplied by rated power into fuel consumption factor. Okay. So this fuel consumption factor, which is determined for the standard conditions, maybe we are going to adjust it according to your project operating factor and the rated power of the machine. So the fuel consumption factor is nothing but 0.25, okay, liters per horsepower per hour. Your horsepower of the machine is 450 and your operating factor is 0.47. So your fuel consumed per hour is 26.44 liters. Now what is the hourly cost of the fuel? Okay, you know the hourly fuel consumption multiplied by the unit cost of the fuel. So it is nothing but 26.44 liters multiplied by rupees 60 per liter. It gives you rupees 1586.4 per hour. So this is your hourly cost of the fuel estimated for this particular machine. Okay, so let us continue our discussion with the estimation of the lubricating oil cost. As we know that how much quantity of lubricating oil is needed, it will vary depending upon the size of the engine, okay, the capacity of the crankcase obviously, the condition of piston rings, and also depends upon the project conditions there. So if the project working conditions are extremely dirty, in that particular case we have to change the lubricating oil very often. So everything depends upon the project working condition and depends upon the company policy, like the interval between the oil changes, number of hours between the oil changes, it depends upon the company policy. Normally you can see that it's a common practice to change oil every 100 to 200 hours. But if the conditions are very extremely dirty, in that case even for every 50 hours we are supposed to change the lubricating oil. Everything depends upon the project working condition and also depends upon the company policy also. Then the total lubricating oil, the amount of lubricating oil is equal to the amount added during the change plus the makeup oil between the changes. That means the amount of oil needed for a complete change of the lubricating oil, and in between we just fill the small gap in between, that is called as makeup oil between the changes, just to fill the small gap left. So every time we don't completely change it. So we just fill the small gap in between. At a particular frequency only we do the complete change of the lubricating oil. So the total amount of lubricating oil needed will be the total amount needed for the complete change plus the makeup oil between the changes. So this information also we can get it from the past experience records, okay, for a similar type of the engine or similar type of the machine. We might have the past records about the machine, the amount of lubricating oil consumption, or you can go by the equipment manufacturer guidelines. So like say for example, if you go through the Caterpillar performance handbook, okay, so for every model of the machine manufactured by them, okay, for different operating conditions, so they have they given you what is the amount of the lubricating oil consumption per hour. So not only lubricating oil, we call it as FOG, so filter, lubricating oil and grease. So the hourly consumption of filters for every model of machine, and hourly consumption of lubricating oil for every model of the machine, and hourly consumption of grease for every model of machine manufactured by them for different project conditions or operating working conditions. You can get the information from the Caterpillar performance handbook. Then we can just multiply it by the unit cost of the lubricating oil or the filter or the grease to get the corresponding hourly cost of the consumables. So the manufacturer guidelines can provide you the sufficient information to get this data. So another the thing is we also have this theoretical formulae available in various literature to estimate the lubricating oil. So this is one such formula. You can see Q is the quantity of the lubricating oil consumed. So in gallons per hour, So this 0.006 is the consumption rate. The consumption rate of lubricating oil is 0.006 pounds per horsepower hour. Okay, so it depends upon the horsepower of the engine. So this 0.006, okay, so we are going to adjust this value according to our project conditions. Say for example, depending upon your horsepower of the engine, you have to multiply this 0.006 by horsepower of the engine accordingly. Similarly, depending upon your project conditions, say for example, depending upon your operating factor. So I discussed about this operating factor already. Operating factor is nothing but your time factor, okay, multiplied by load factor. Okay, so how long your machine is going to operate in 1 hour? Okay, what is the working efficiency? That is your time factor. And load factor is nothing but in your production cycle, okay, for how much duration the machine is going to work at full power, and for how much duration it is working at average power or the lesser than the full power. So if you know that, you can calculate a load factor. So the product of these two will give you the operating factor. So according to your operating factor, you have to adjust this theoretical value 0.006. So then another thing is your crankcase capacity. That will depend, okay, vary from machine to machine. So according to the crankcase and between the number of hours between the changes. That depends upon your project working conditions, whether it is too extremely dirty condition, then you have to change it frequently, and also depends upon the company policy, as I told you earlier. So the number of hours between the changes, and this 7.4 is a conversion factor. So this Q is nothing but the quantity of oil consumed in gallons per hour, but the consumption rate is in pounds per horse per hour. So the conversion factor is 7.4 pounds per gallon. So with this formula, you can estimate the lubricating oil for your project condition. So whenever you take some theoretical value, you have to adjust it according to your project conditions, based upon the horsepower of your engine, based upon the operating factor, based upon the crankcase capacity, based upon your company policy of number of hours between the changes of lubricating oil. So this is how we do. Okay. So similarly, this formula, here we are estimating the quantity in gallons per hour. So I have just converted the same formula in SI units so that we can estimate the quantity in liters per hour. That is the only difference. Okay. So here you can see the consumption rate is 0.0027 kg per horsepower. 0.0027 kg per horsepower. Accordingly, you have to adjust according to your conditions into horsepower, into the operating factor, into the plus crankcase capacity, divided by the number of hours between the changes, and the conversion factor here is 0.89 kg per liter. So the final quantity you will get it in liters per hour using this formula. So these are the theoretical formulae available in the literature so that you can estimate your lubricating oil per hour. So the other important component of the operating cost is the mobilization and demobilization cost. Okay, so already we discussed about the mobilization. Say when we purchase a machine, okay, so the initial cost is inclusive of all the freight charges, okay, to procure the or mobilize the equipment to your project site. So apart from that, you may have to shift the machine from one project site to another project site. Okay, so in that case, you have to calculate the mobilization cost separately, and it will be included into the operating cost. Okay, so the cost of moving the equipment from one job site to other. So this includes your freight charges, your transportation charges, as well as your the other loading charges and the unloading charges of the machine. So loading, unloading charges, and the road permit. So even the road permit charges for mobilizing the equipment to the particular project site and getting the equipment ready or installation, assembly charges, everything comes under this mobilization and the demobilization cost. Okay, everything should be accounted accordingly, and you can estimate the hourly cost. Now next is your equipment operator cost. This includes your normal operator hourly wages. Okay, so normal hourly wages of the operator, and also you have to include all the other benefits, like say for example is overtime charges, benefits, other bonus what he gets. Okay, everything should be included under the equipment operator cost. Even the workman compensation insurance premium which the employer pays on the behalf of the employee or the worker. Okay, so that premium is also included in this workman compensation insurance premium. So everything is included in this operator cost, and you have to calculate the corresponding hourly the operator cost. So operator wages are added as a separate item and added to the other calculated operating cost. So the next component in the operating cost is your special items. Special item cost means they are called as high wear items. That means they deteriorate, they are subjected to wear and tear at a very faster rate. Okay, they deteriorate at a faster rate. Their life is very shorter. Say for example the bulldozer blade. Okay, at the bottom of the blade you can see the cutting edge. So the cutting edge is just bolted at the bottom of the bulldozer blade. So this cutting edge gets worn out fast depending upon the project working condition. If it is a very rough or severe working condition, wear and tear will be very faster. So the cutting edge gets worn out faster. You have to replace the cutting edge at a very shorter time interval. Okay, so generally we don't replace the blade frequently. We just replace the cutting edge frequently. So these are called as a high wear item. Similarly, your ripper, which we use it for the loosening the earth, at the bottom of the ripper you can see the tip. Okay, this tip also gets worn out faster. We have to replace the tip in a shorter interval. This picture clearly shows the cutting edge at the bottom. So another thing is your this is an excavator bucket. So you can see at the edge of the bucket you can see the teeth of the bucket teeth. This also gets worn out faster. They are just bolted on to the bucket, so you can just replace it very faster as it gets worn out. So basically these are high wear items which gets worn out faster. So a special item means cost of replacing the high wear items such as the ripper tips, blade cutting and end tips, your bucket teeth, all these are calculated as a separate item or the special items because they have shorter life when compared to the service life of the remaining part of the equipment. So for this also you have to calculate the hourly cost. To know the hourly cost, you should know the unit cost of the item and you should divide it by the expected life of these items. So this information you can get it from your past records or from the manufacturer. So manufacturer handbook will provide you the information on the expected life of this particular unit for different operating conditions. So based upon that you can get this information, and also the unit cost you can get from the manufacturer. So based on that you can get the hourly cost of these special items. So what are all the components so far we have discussed under the operating cost? Let us summarize. So maintenance and repair cost, your fuel cost, okay, lubricating oil cost, all these are consumables, okay, the mobilization cost, equipment operator cost and the cost of special items or high wear items. So all these things makes up your operating cost of the machine. So let us just summarize. With this we are coming towards the end of the lecture 4. So basically, as I told you in the beginning, the operating costs are highly variable cost, unlike your ownership costs which are relatively fixed. Okay, your operating costs are highly variable because they depend upon the usage of the equipment. More you use the equipment, more the number of operating hours, the fuel consumption is more, the repair and maintenance will be more. So everything depends upon the usage, depends upon the type of the equipment. If it is going to be a very highly mobile equipment, its operating cost will be more. So depending upon the nature of the job, nature of the working condition. And the same machine when put in a severe working condition and when put in a normal working condition, you can see there will be huge difference in the operating cost. Okay, we discussed all those things with various illustrations. So this information on the operating cost, you can get it from the past experience records. If you have accounted or if you are maintaining your records properly, from your own past records you can get the information on similar equipment, or you can go with the guidelines given by the equipment manufacturer in the equipment handbooks. Another important thing to be noted is your maintenance and repair cost of the equipment. Okay, it can be expressed either as a percentage of the depreciation or it can be expressed as a percentage of the initial cost of the machine excluding the tire cost, because tire repair will be considered separately because the life of the tire, the deterioration rate of the tire, okay, everything is going to be different from the remaining part of the equipment. So when you calculate the maintenance and repair cost of the equipment, we exclude the tire cost from that. So if you don't have much information on the tire repair cost, you can take it as, you can just add 15% to the tire replacement cost to get the tire repair charges. And another important thing to be kept in mind is if you are going to use the theoretical values of fuel consumption from some literature. So for the particular type of machine, you have chosen the fuel consumption factor from a literature where it is derived based on standard conditions or maximum output rate. So when the fuel consumption factors which are given in the literature or given based on standard conditions where the machine is working at the maximum output rate, then you are supposed to adjust those fuel consumption factor according to your project condition. So how to adjust it? According to the horsepower of the machine, okay, you have to multiply the fuel consumption factor. And another important thing is according to the time factor and load factor, so which is nothing but the operating factor. So according to your operating factor, so you have to adjust those theoretical values and so that it can reflect your project conditions accordingly. So with this, we have come to the end of the lecture 4. So these are the references which I have used for this lecture 4. So basically, I would like you to download this Caterpillar Performance Handbook. Even the link is given. So as I mentioned earlier, lot of information on the fuel consumption, your filter, oil, grease consumption for different models of machine, and repair factors, okay, the tire life, okay. So all these the values, you can get much clear information by going through this handbook, and also there are a lot of illustrations worked out which will give you more information to learn the subject. So there are also other handbooks, not only Caterpillar Performance Handbook, there are so many other handbooks supplied by different manufacturers, so you are free to download it and go through it. And this is another the handbook which is published by the US Army Corps of Engineer. This also provides a lot of information on how to estimate the equipment cost. Okay, thank you.